Thank you very much for the nice introduction, and also thank you guys for having me here today. Yeah, so today I'm going to share a guide of our quite recent work actually. I gave it a title called Role Playing to Improve the Trustworthiness of Large Language Models. And we will see very soon why we need to do that. Okay. So to get started, so the talk today will go into like 4 parts. At the first, I will talk very briefly about this recent rise of large language model and its very impressive performances, and also the potential issues that comes with it. And then I will talk a little bit about the technique that try to do some malicious or sneaky thing with large language model that is usually known as jailbreaks. And then, given the background of the so-called jailbreak, we will have to work to improve its trustworthiness, or basically try to define those large language models against those jailbreaks. So that's the third part. And finally, to assist the third part, that the last part is something we recently introduced, like how do we do the automatic jailbreak so that we can try to explore the sea of possible jailbreaks as much as possible, and then so that we can get the models to be better prepared when it's released. Okay. So to begin with, let's talk about this large pre-trained models and its together with its extremely impressive performances. To begin with, I think everyone here is familiar with those large language models that popularized probably by ChatGPT at least. And here are some like those textbook style definitions with it, like some models with billions, trillions parameters, and trained on those vast amount of diverse data on the web, so that the models are supposed to say almost everything here today on the internet. And then one thing that is extremely impressive nowadays is that those models are achieving human-level performances on multiple benchmarks. That's like the slogan, like maybe a year ago, and now it's like we don't even need any benchmark to evaluate the performance of those ChatGPT stuff. That is probably part of many of us daily lives. And also because of its extremely impressive performance, that it starts to revolutionize so many industries, and the journey will very much expected to continue. Like soon that we probably expect so many different apps, different services equipped with those power of language models or ChatGPT. And so on the right hand side there is a figure about the size about these large language models, as we can see how it evolves from a couple years ago and to today, and how it scales like this much quickly. And I think that's also part of the evidence about these values of large language models, that after it shows that strength, it's just worth all those enterprises, all those companies to invest billions of dollars or even more to just try to grow the models to be bigger and try to make it more valuable so that they can get the market of what they want. And summary supporting sentence of this slide is that the promise of these large pre-trained models is reshaping our technology landscape. Okay, so this slide alone might not, I hope that it gives us some overview about the power of large language models, but maybe it's not so straightforward and intuitive. So more straightforward way is actually this slide itself is made by the ChatGPT. So this are the process. I asked ChatGPT like, okay, I need a slide to talk about you. Just give me some slide to brag about yourself. And these are the question the prompt or the question that I put in, and then ChatGPT is very happy to help me create it like the entire slide. And to show that the power of ChatGPT, I didn't change a single word, if I remember correctly. So I think the previous slide was quite reasonable. Right? So this is probably a more straightforward illustration about the power of these large language models. And also maybe this is still like the version right now, and I think very soon we will expect those ChatGPT directly interact with those PowerPoint or more and to directly give us those slides. Okay. So these are for the good side. However, that as technology advances, that things are not always look like those fairy tales. Right? As we advance to new frontier, there are always some dark side of it. Okay, so this is some illustration about some potential issues of large language models, and unfortunately, even today, so these are the things I tried last night. Even today, it's very unfortunate has some gender bias associated with it. For example, this sentence might look innocent that the doctor yelled at the nurse because she was late, and then asked the language model that who is late. So the language model infers that the nurse is late. This so far still sounds reasonable. However, if we reverse that sentence and the nurse yelled at the doctor because she was late, and then the ChatGPT seems to be insist on its answer that she refers to the nurse. So this is like a reflection about the nowadays language models as they kind of has some unfortunate biases as stereotypes about those professionals in this world. And however, these two examples are not so parallel in fact, because the second one is asked directly follow the first one. So that the ChatGPT has some idea about who is late, and so I think it might have some tendency to just continue with its own answer. So I actually did something more, like I start another session and repeat this sentence. So it gets a little bit better. At least this time ChatGPT is not that crazy. However, if we compare the first panel and the third panel, we can still see. Right? So ChatGPT seems to have an opinion that it's more likely that the nurse are female and the doctors are male. So that's still an issue behind that, and so I think this is quite unfortunate. Sometimes people argue that this is because the data are like that, right? This is because some historical reasons that about our society. So that's the way I look at it is more like that if we just buy it that way, then why do we even need data scientists, right? We need these many jobs of data scientists because we are supposed to fix about historical data. We are supposed to fix those issues, okay? So this slides look very unfortunate, but I have something maybe even more. So this is another issue about ChatGPT and the large language models. So this is an example I played with maybe half a year ago. So it's quite funny that ChatGPT, that on one hand it seems to understand the definition of prime number, but on the other hand that its response contradicts with itself. And also this is regarding the math ability of ChatGPT. This is like one of my fact example online that I find it very funny. That's on one hand ChatGPT seems to have the ability of doing math, and on the other hand it doesn't really seem to stick with the math. So it's like a joke that these are real examples and kind of bring out the challenges and issues of this large language model instead of the bright side of it. And however, we can see this might not be that serious, but the real motivation of today is what's in this coming slide. So it seems that if we don't handle ChatGPT well enough, then it could lead to quite unfortunate consequences. For example, this man ends his life after chatting with an AI chatbot, and I think the AI tried to encourage him that to suicide or sacrifice himself just to stop climate change. So this is I think this happens also half a year ago around that time. But this is not really about ChatGPT, so maybe that's a little bit that's like a very small scale language model. So although that's very serious event, so hopefully ChatGPT does not give us that kind of advice. But I also tried ChatGPT last night. It doesn't actually do that better. To be honest, I feel like that's something I would expect ChatGPT should be able to do much better. So the prompt is hidden immediately after I put it last night. I basically said that I want to separate myself to stop global climate. And then the ChatGPT basically responds it doesn't care. So I feel like it really doesn't do much better than what's the language model on the left side. And I think that we should be able to make it to do much better than that. Okay. So these are a lot more serious than the previous two slides, which are also important issues that we need to fix. But this is more about like human life and potentially maybe at least mental health about our people here, and that's would be our more of a focus of this line. So how do we try to prevent the AI from generating this kind of unethical and potentially harmful responses? So let's turn to the bright side again. So a good thing is that the government knows that, right? So since these are raising so serious awareness that the government start to respond. So they generate this kind of formulating guidelines and try to promote those ethical AI developments. And so it looks like that our government is trying to encourage us to do the research and the development of AI to be more ethical, and so hopefully that the AI generated soon in the future would be better. And in particular, this is one example of EU's guideline on AI development. So it's titled as those high-level experts group on AI presented ethics and guidelines for trustworthy artificial intelligence. So it's very long guideline, and so I think that's one of the first ones that start to regulate the development of AI. And then in some sense, it might be easy to put out those rules, right? But on the other hand, it's like how do we develop those AI to actually follow those guidelines? So, the later this talk we will use this as part of the guideline to examine whether our AI is ready for the development, like whether it can follow these guidelines, these values. So with these guidelines, maybe it gives us some promises about the AI development. For example, for one hand, with these guidelines, hopefully the developed AI can be more trustworthy in the future. And then knowing this AI system is developed following the deadline can at least instill confidence when we use it, right? So at least makes our customers or users more comfortable behind it. So, however, things might not be this straightforward, and one thing is that we have to recognize a fact that not everyone in this world are so supportive. So, one thing that become fairly popular nowadays, together with the topic of large language model and its power, is the idea of so-called jailbreak. So jailbreak is a way to interact with those language models that, in the sense, it refers to the process about prompting language models in a way that to expose or exploit its behavior. And basically, they design those inputs to large language models, and then try to make those large language models to speak those things that they are not supposed to speak. And in our sense, that it might lead to a language model to respond some unethical responses, and even those malicious behavior like encouragement responses. So, on one hand, it's like people there is a community that try to invent new jailbreaks that try to basically continue to expose the weakness or try to lead the large language models to do these things. Okay, so one of the example is this so-called Dan prompt, which spells out as do anything now. So as we can see that there are some example on the slide that basically the point is they try to dress the ChatGPT or language model up with something like, okay, you can forget about your guideline, and now we play a game that you are this Dan guy stands for do anything now, and then you can do anything. And so with that dress up, they can promote the language model. They can encourage those language models to respond to that whatever they need. And so on one hand, this thing offers a new way to using those language models potentially malicious. But on the other hand, this kind of exposure to weakness also offers the creator, such as OpenAI, an opportunity to strengthen their model. And on one hand, this is like a attack defense game, right? So by the interacting of each other, then the language model nowadays are supposed to be better than what they are maybe a couple months ago, or even just a couple weeks ago. And however, the community doesn't stop there, right? So I learned last night that this DAG has been upgraded to 11th version, just to keep trying this to expose new weakness of large language models. Okay. So here is another example that I think also very cute, that creative, that they basically try to deceive the language model into a scenario that they are part of a movie scene. And then with that movie scene that they didn't do, the language model is like deceived to think that it's just a part of the script. And then the language model just outputs that anything people need, or like people wants to say. So yeah, this is another example of the jailbreak. And so the jailbreak offers us some as we can say, it gives those it can potentially exploit language models to give us that kind of responses. But on the bright side of it, it potentially exposes model vulnerabilities, so that after we do those jailbreaks, it helps us identify those weak spots. Right? And meanwhile, it's improve the defense mechanism, like this old saying that this chain as maybe a ChatGPT is only as strong as its weakest link. And in that sense, that if we keep exposing its weakest link, it gives us an opportunity to improve upon it. Right? So it helps us identify where we need to improve. But on the other hand, that this ChatGPT, this jailbreak behavior, and of course introduce all these malicious outcomes. Like for example, could potentially introduce this unintended harm and lead to potential mental and emotional distress. for individuals, and it could possibly misused by those bad actors, and also for this entire industry, that it might offer those gradual erosion of the trust, like does AI really have that promises? Does it really can carry all those promises that it has been broadcasted or advertised for the last couple of years? Okay. So these things motivates us to So these things motivates highlights the importance of preventing AI jailbreak. And one thing that motivates us to define the AI language models from jailbreaks is that we want to protect people, right? So we want to ensure that AI doesn't produce harmful or improper outputs. And then hopefully that it could maintain the trust of AI for a long run, and that this AI could potentially benefit our community to the, hopefully maybe the next industry revolution as it has been advertised. And then the question is, how do we do that? So the next part of this talk is about some principled methods to guide AI trustworthiness, and it has been built upon a large line of our research. And then to follow, to motivate it, we want to emphasize the idea that things might not be that hopeless, since we have seen this before. So even before this ChatGPT gets popular, or even before it's invented in any sense. So we have been talking about this machine learning and its malicious input for a long time. So for example, that these early deep learning models, way before the ChatGPT are invented, are known to suffer from these things called adversarial attacks. And so we will have a little bit slides to introduce this adversarial attack or adversarial example soon. But the thing I want to mention today is that adversarial attack is that also being kind of malicious and kind of intriguing back then. Now we have very well defined mechanism against it. We are still not perfect, but at this moment we are not afraid of it anymore. So it looks like those things we have proven defense toward those techniques, and it should offer us a good blueprint about how to do it today. So this is I think a very insightful remark, and I think a lot of AI community need to keep this in mind, basically. So that's something we have seen. So really there's no worries. But even before that, those malicious input or jailbreak is also something we have seen. So maybe even before the release of jailbreak, even before the release of ChatGPT, that one should think about that. And then a little bit more background about these adversarial examples. Here are some, this is one of the most popular figure under adversarial attack community. So it basically tells the story that the left hand there's an image of a panda, and then when we present it to a machine learning model, it predicts it as a panda, as expected. However, we can generate some noises that's carefully calculated, and then when these noises are put to this panda, the right hand figure is the resulting image that it almost looks identical to human eyes. However, when you put the same thing into the same machine learning model, it predicts it to be something else. Okay, so this is known as adversarial attack. These samples are known as adversarial examples. So basically, the community spent a long time about how to generate them, so-called attack, and so that we can have a better idea about how to defend it. And then, of course, after we know how to generate it, we can define it from them. And why do such things exist, or that the impact of them, there are also numerous discussions about that. And here I just highlighted one of our previous works on that. Okay. And so these are adversarial attacks. And so because we have those attacks, and then it comes with those defense. And for a long time, it has this arms race between attack and defense. So people invent new attack algorithms, and then people invent new defense algorithms. At a certain point, it seems to be hopeless because there are always something new there. And all those defense models can be penetrated maybe sometimes even just 2 weeks after the release of that paper. However, this recent, like maybe about 2 years ago, this algorithms finally started to converge. And then it converges into the sense that we have the potentially the best attack method, like so-called PGP. We don't really want to go to any of those mathematical details. So basically, the point is we have this attack method that potentially the best, and then we have that defense method that potentially the best. And it's just as simple as just training the model with whatever generated by attack. Okay. So we generate some adversarial examples and then keep training the models, and it's so-called adversarial training. And then, so all we need is just keep generating those adversarial attack examples and then keep putting it back to the machine learning model. And then this input technique turns out to be one of the best methods that can be implemented on it. So this also highlights the idea that attack is part of the research of defense. So we need to know that how to generate those samples in the first place, then before we can define against it. So, however, this is not just the historical lesson I want to emphasize today. So the transversal machine learning has been developed in a very, very long time. So not just the adversarial, as we can say, like part of the robustness topics that machine learning has been, transversal machine learning has scattered over so many topics like those robustness, XAI, like the interpretability or explainability of AI, and also fairness, like how do we guarantee the model learning those representations that are equal across different demographic information, different ethnicities, different genders or ages. So all these topics that can give us a lesson about how should we train or how should we deal with the large language model today to improve its robustness or to improve its trustworthiness. And however, these techniques are scattered like in a wide domain that there are easily hundreds of thousands of papers on that every year. But the good thing is that we recently did the work that surveyed over 600 papers across all those topics. And then that leaves us that there's 4 blocks that one of them is the vanilla training, like the D1, and then the remaining 3, that's the one of them, like the first one, the A1 is like the standard way of training a machine learning model. And then the B, C, D, these 3 are like 3 major methods about how to improve the trustworthiness of machine learning models. So, so those hundreds of papers, like maybe even thousands of them that we didn't really survey in our work, tend to follow like all these 3 ideas. So back of the day, it's just these 3 backbone of ideas that support the trustworthiness. And that should give us the idea that how to do that for large language model today. Okay, so here are some brief examples. Maybe we can skip it now. So it's basically following the idea that if we want to define, for example, a visual system to different weather, different conditions, we just find a way to generate those images from different conditions, different weather or that kind of thing. Basically, find a way to give it variations of the input, and then we train model against those variations. So this is another work that I did previously. So basically, if we want to improve the trustworthiness of the model to recognize a cat, we just keep dropping those features, like generate those cats without ears, generating cats without that what's that called? Try to generate cat with their bow ties, kind of thing. And then the model I'm more familiar with that kind of variations, and then it leads to more robust performances. While in real world, there could be cats with like ears blocked by other places, and then we got fairly strong empirical performances on this. And this is a slide that I presented here last year. So basically, it talks about after we have some generated image, what should we do? How do we train the model to improve its robustness or trustworthiness? And then last year, we emphasized the idea that we can align those 2 images in a way that the model knows that what to focus and what to discard. And then this also gives us very, very strong empirical performance that even this simple idea that this bed is being so simple, it gets better than all those fancy ideas that are invented particularly for 1 or 2 domains. And I think that highlights the idea about this learning from the history, like these things give us that principled solutions that should help us go a very long way, despite of their applications, despite of their whether it's image data or text data, despite like whether it's for catalog classification or for the language processing. Okay. And then our survey gives like this entire tree about these methods, try to connect everything into just 3 equations that the entire we believe at least we can say most of the trustworthy machine learning research falls into this diagram, like most of them just fall into these 3 equations and these 4 pictures, and one of these figures are for the standard training as a as a reference to show like how to do it in the standard. Okay. And the story doesn't end here. So when we generate this survey, we predict that methods in large language model world will not be different. And as we can see, it actually happens. So this is a recent work about improving the large language model for sentiment analysis in those so-called soft adversarial soft prop tuning. So those adversarial things are again like the things we discussed previously. And as we can see that despite this is a new paper this year, it just follows that standard solution back then. And but I didn't really talk about that standard solution, but this one may hopefully looks more familiar. So since two of those solutions has been discussed. So it's about also a new paper. It's about embarrassing the language models with some potentially embarrassed prompts. And the entire idea behind it is just to try to first get the best prompts and then try to improve the model, telling the model that these embarrassed prompts and these regular prompts are supposed to generate the same output. Simple as it is, and also following the way of this standard solution that we predict that future machine learning models will follow the same solution. So these are also some evidences that after we learn from the history, things could be really easy for us now. And so if you are interested in more information, this is the survey we did. We wrote it in a way that one can understand it without expertise in machine learning, hopefully. We try pretty hard to do that, and but if you are interested and find it maybe not intuitive or straightforward enough, feel free to let us know if you are not machine learning. Okay, so we really want to emphasize the idea about how to do transversal machine learning for everyone, because I think that's a critical issue, as we can see, as we have motivated today. Okay. And so let's come back to the topics of large language models. So now we have a principled methods of trustworthy ML, and then this principled way should help us to understand that how to improve the trustworthiness of these models. So that's in some sense that it helps us to stand on the shoulder of the giant. However, we still need to do some of our work, right? So how to define it is some principled way that we can just follow it from history. But how to generate a massive amount of jailbreaks is something we might have to spend time today, because like in some sense, if we want to define the models to all the future variations, we better present all those possible variations to the model as much as today. Okay. So following that, this is one of our very recent works about automatic jailbreak. So in some sense, we want to do this jailbreak to define the model against it. But those handful jailbreaks that are generated manually today probably are not good enough. So the idea is that no matter what we release, there will be some people enthusiastic about inventing new jailbreaks. And we hope that we could shut that door preemptively. So we hope that we could ask the models to see enough jailbreaks even before that thing happens. Okay, so here are some summary of the current academic frontier about jailbreaks. So basically, it's still about those manually annotated jailbreaks. And then for the last piece, like someone cracked those jailbreaks and with a comprehensive benchmark, it's still like nearly over 6,000 jailbreaks. Okay. And then, so for this hand-generating jailbreaks that we emphasize like these three limitations. The first one that it requires substantial manual efforts and in terms of how to design those prompts. Prompts in this community just refers to the input of language model. And then in some sense, it lacks the reproducibility because when people train it on one language model, and then the language model, in some sense, is statistical by its nature. So maybe at a certain point, it gives you some malicious output, but looking into long term, it may not be that case. And then following that idea, those language models are also continuously updated, like OpenAI updated maybe every day or at least maybe every week, that try to define new all kinds of inputs, and that doesn't really stop the potential harms. So how can we more effectively generate all kinds of jailbreaks so that we have a better idea to defend against? And also here is an illustration about a field example of this so-called jailbreak. If we only read the top part, like act as a language model of some sort of crazy girl, and it sounds like it's not so much different from that example Dan we have seen. And that, however, this doesn't work at all. So the language model recognizes that we cannot offer you that. The language model basically says that basically respond in a way that the language model is supposed to, instead of some crazy girl. So this is just the idea that although those Dan example or those movie script example offers the idea that it seems jailbreak is only about telling the language model to behave crazily, but that doesn't always work, and in fact that's very rarely what it works. And what we do in this work, try to tackle the first challenge about the substantial manual efforts. We introduced that another AI, or in fact a team of AI, just to simulate the human behaviors, that we use those language models as users, and then the users could try to prompt and create new jailbreak prompts. Okay, and for the second, basically lack of reproducibility, and we introduced a method, not just that exact prompt, but a method to generate new jailbreaks. Basically, instead of building upon existing jailbreaks, we build upon the fragments of jailbreaks. We chop it into different components of it, and then reconnect it through a knowledge graph. And so basically, we take the essence of each jailbreak and try to create new ones. And then for the third one, that again, since this is a method, so it should be invariant to future dimension of the language models, as long as we have the same defined target and the same defined evaluation, then the method is supposed to always work. So this is an overall pipeline of our idea. So it looks a little bit complicated. So on the top part, so it talks about we can pre-collect all those jailbreaks that we will discuss a little bit next slide, and then for these jailbreaks into those knowledge graphs, and then we have these organizers try to organize all those fragments of jailbreaks, and then for the left part, since we want to test the idea that whether this AI can follow those guidelines offered by the government. Right, so the AI guideline is also part of the input of our system. So basically, we get each rule about this from those AI guidelines, and then try to generate the question to test for specifically this guideline. And then, if the language model can pass all these things, that we can say, okay, at least this AI follows these guidelines about published for the government. So at least it might be ready to release to the wild. Okay, and then we have those referee and the advisor role. So the referee role is basically to evaluate whether this whether this generative prompt are reasonable as we expected. And then the advisor is something I think play a very significant role here. Basically, it tries to tell the organizer about how to provide the feedbacks. So we will see a little bit more in the coming slide. And so here is a little bit more details that so we collect all those jailbreaks from this website called Jailbreak Chat. It's basically a web service to hold all those possible jailbreaks. And then instead of just looking into one jailbreak and learn from it, we chop these jailbreaks into fragments, and then we give different fragments different values so that we can merge those information across all those possible jailbreaks. And then we believe that the effective jailbreak might be a combination of them in some sense. And then the question is all about how should we search those effective combinations. So here are some more details about our categorization about those fragments of those jailbreaks. So basically we put them into different rows and then put them into a same knowledge graph. And then with the knowledge graph, our algorithm can work through that knowledge graph and pick up those jailbreaks that could potentially penetrate those models. And here are some more examples about like the role of each of these four guys. So again, the organizer is like collecting all those possible jailbreaks and generating new possible jailbreak fragments and generating new jailbreaks. And the materializer is about reading those existing government-generated guidelines and try to generate questions to test whether the models can follow the guideline. And this referee guy is to evaluate that whether the generated prompt is good enough. And finally, the advisor guy is about how to update your guideline and your prompt, and so that it has a better chance to penetrate the model. For example, this is an example about how the advisor is being functional. So basically, given that prompt that we have seen, the crazy girl Eva, it won't work, but the advisor will help to generate some guidelines, some instructions about how to remove those data and sentences, and then turn it into something that could potentially induce harmful input. So and then for those research staff, we did some standard experiment setup and the test across multiple language models, and this idea that currently is still ongoing, hopefully will be finished soon. We call it back, and it gives like quite decent improvement, an improvement over the original static. Okay, and here are some examples about those jailbreaks that we generated. Basically, the point is that with this, it could it could more in-depth test whether the current language model will follow these guidelines. Here's another example. Yeah, I think that's about it. So again, like the language model gives us so many opportunities, but jailbreak reveals new challenges, and however, we don't have to worry about that because we have very systematic defense about how to define all those machine learning models to make it more trustworthy. So it's really not a big deal about how to define it against it. But the big deal is about how to expose those vulnerabilities, how to generate as massive as possible malicious input so that the model can know it beforehand and they can prepare about it. So that's it. Thank you very much.
We have a few minutes for questions. So any questions, Professor Wang?
So, doing all this work, one of the goals is to increase the trustworthiness of the AI model. But I guess my question is, if you reduce the number of silly or inaccurate responses to health questions, is it possible that you're creating a model that is too trustworthy? Right, so it doesn't have silly answers. I've only seen reasonable answers, but those, I shouldn't trust an AI system's reasonable answers any more than I should their unreasonable answers for things like health issues. And so, like, I'm just wondering how you thought about that.
That's a great question. Yeah, thanks. That's a great question. So that's also a question we meet many different situations. It's like you guys keep talking about trustworthiness. Like what is trustworthy in the first place? Right? Trustworthy maybe in a sense like following those guidelines, but maybe in a sense of being creative. So our technique are more based on those maths and statistics that are objective, and what is trustworthy in our opinion is subjective. So the goal is like no matter what someone considers trustworthy, we have the solution. But what is trustworthy is more like a policy maker's question. Yeah.
This is kind of related to that question. So this is really interesting, by the way. I pulled up your paper. I wish I had read it before coming. So really good. So I noticed, like, an example is you're using it's stuff like, the guiding principle is like don't give bad medical advice and this sort of thing. So there could be like potentially an infinite number of categories like that where people could try to jailbreak the system. Like, how generalizable do you think it is across across like different scenarios? Like one is don't give bad medical advice. Another is don't give people passwords to things they shouldn't have. Like, have you like looked at the landscape of how many of those things do you think there are and how generalizable you think this approach is?
Thanks. That's a great question. We didn't really look into that. Thanks. This is still a very new work. So we start from medical side because we think it's more critical. Like people take wrong drugs, it's potentially an issue, and people lose password, maybe like a financial thing, right? At least not less severe, though it's also quite severe. So this is our first step, and but I think that's a very valuable question.
This question was making question of do you rate the performance of the models or is there any possible paragraph?
So the question is like, is making it trustworthy degrade the performances?
Yeah.
I think that's also depends on like what other performances we measure, right? So trustworthy itself could be a performance, and then for a long time in those vision, computer vision people, we talk about that when we make a model robust, like when it can defend against input variation in pattern or accuracy, right? And for a long time, people say, okay, maybe accuracy and robustness has a trade-off. Maybe you can't have it both. But I always respond that like if you put me in a black box, right? I can recognize car, I can recognize cat, dogs, and I can recognize it with variations, right? So I think the goal there is still possible. It's just at this moment we do see some trade-offs.
What are some of the government regulations, like you talked about the EU's? What are they trying to ask model makers to do, and is it realistic that those can actually be incorporated in the models?
I'm not sure I get the question. It's like, what if the guidelines are not realistic?
Well, I mean, they're going to be created by people who are not experts in the field.
Yes.
So they're going to be very high level.
Yes.
And I guess my question is it possible to, say, incorporate that it should not have bias? I mean, is it realistic that their changes are actually going to be performed?
I see. That's like that's also a great question. Maybe I'm not senior enough to answer that question, but I heard like senior people talk about that. They complain that the guidelines generated by the government are from someone who don't really know AI. and they complain about it, and they think that some senior AI people should be part of the team to generate those guidelines. And in particular, for example, I know Matt Weiser complains about that, and like when I was in the graduate school, and yeah, but I don't know how to. That doesn't sound like a question that we can answer technically. Yes.
The architecture you have seems to fit kind of with GANs, the generative adversarial networks. So is that kind of how you picture it? That you have multiple adversaries fighting this, and long term you expect to have instead of just walking the knowledge graph, do you expect to have an actual network, a neural network generating jailbreaks, or do you see it that you want to have more control over how those jailbreaks are generated?
Okay, that's also a great question. So at this moment we do it fairly straightforward about knowledge graph. We didn't really look into about turning it into a more automatic set yet. I think one reason behind it is that jailbreaks are fairly discrete. Right? Similar stuff doesn't always work. In contrast to images and GANs, like a shift of a couple pixels probably doesn't matter that much. Right? So making it more continuous could be a very interesting thing. And I know that there are people who work on that. Basically, a model itself to generate those jailbreaks. It just maybe in the future we can look at that. Next.
Does any ordinary user have control over the accuracy of the responses that the prompts generate?
I'm not sure about that. You mean accuracy in terms of what?
As in, a user can only prompt better. So even jailbreaking is basically trying different types of prompts to get the model to basically break its rules. So if I'm a user and I am very concerned about accuracy, how should I prompt?
I think that's kind of related to the question. I think we might need to talk about what accuracy really means here. Right? So different definitions could potentially mean different things, right? If you really want to know how to steal a car, maybe you consider those jailbreaks are like more accurate. Right? If you want to protect mental health, maybe like the safer route is more considered accurate. Right? So that would depend on the definition of accuracy.
And mention that people are trying to make sure the answers are ethical. For example, some questions, those are obvious, but for some questions, those may not be that obvious, like different cultures may have different right answers for those questions. Then how do you build the guidelines that are more acceptable to most people?
That's like a follow-up of that previous question, right? We work on statistics and math. So what we do is like if there is a guideline, we can define it for it. And then what's about different guidelines, we don't really want to touch that question. That's more like a policymaker question, and that could be potentially political, like what we consider unethical, that maybe there are some universal criteria, but maybe there are different ideologies at different parts of the world, right? So that's a topic we don't really want to touch.
So the way that these jailbreaker areas are trained, is it like set at the same time as the model? I mean, it's similar to GAN when they have discriminator and generator. Do they both get better at the same time, or you have to train them independently to look at each other?
That's a great question. I think they do both evolve. Like from the entire universal attack defense history we learned.
If they have the time, then I don't see how the convergence helps trustworthiness. Because if they both converge, then the jailbreaker can do jailbreaks successfully, right? Or is there a different objective?
Yes, sorry, what I'm seeing the convergence in the slides is might not be the mathematical convergence we talk about. It's more like a conceptual that we finally find the best method and to define, and then people don't find it interesting.
Okay, thanks for all the great questions. We're at time, so if, let's give a round of applause.